Okay, this is my correction video for the Irregular Killer Sudoku 4 puzzle. I posted earlier today. I just realized I made actually a pretty bad assumption here. And the assumption was this must be 1 here. So we have to actually go back through this and find out how to solve this without that being a 1. Those two digits being a 1, because it could be a 0-2 pair here. And I did not, I messed that up pretty badly. Okay, this is gonna be very beginning. So if we can figure out that those have to be 1, everything flows from that. So we will basically try to go back in time to before when that was not, but the problem was I made that assumption pretty early on. So that's pretty bad. Let's just continue. Let's see what we can do with this. Yeah, that's really early on. We might have to, let's just restart right now. Yeah. We'll keep the time. Okay. This is 7, 8, 9. We're just basically trying to prove this is 1 and 1. We know it has to be 0, 1, 2 here. This has to be 7. This has to be 6. This is 8. This cannot be 8 here. This again must be 0 through 6. This must be 0, 1 through 5. This has to be 0 through 7, but no 1, 6. Therefore, this has to be 8 and 9, 8 and 9. This is 6 through 9. This has to be 0, 1, 3, or 4. These are 0 through 6. And this has to be 0 through 5. This again cannot be 0 and 7 here, so it's 1, 6. 1, 6, 2, 5, or 3, 4, adding up to 7. This cannot... 6, 7, 8, 9 has to be here, which means 6, 7, 8, 9 cannot be in the remaining digits in column 2. So this is 0 through 5 also. This is 0 through 5. This can't be 1 because that must have a 6 there to add up to 7. This digit cannot be here in this cage because it shares its same cage with these digits. Cannot be these digits because it shares the region with those digits. So this must be 8 or 9, which makes this a 7 because of the 8, 9 pair in the cage. That means this can't be 0, 7. It's 1, 6, 2, 5, or 3, 4. This is still the same. This adds up to 10. So you have 1, 9, 2, 8, 3, 7, or 4, 6 adding up to 10. This can't be 7 or 8 or 9. And it can't be 4. Therefore, this must be... where is the 6 then in column 8? Cannot be in this region because of the 6 in the region. Can't be here, so 6 has to be one of these two digits, which means this cannot be 6 here. So this is not 1, 6. This can't be 6, or actually this could be 6. This can't be 6, so this is 1, 2, 3. This is 5, 6, 7. One cannot be in any of these digits here. So 1 has to be one of these 5 digits here, which means 1 cannot be either of these digits. This can't be 7 and 1. Again, you have the same problem then. You can't have 7 and 1 because of the 7 in the column. you have the same problem here. This can't be 2, 5 because then that would eliminate 2, 6 here and 3, 5. So this has to be a 3, 4 pair, which eliminates 3, 4 in the rest of the column. This can't be 3, 4, therefore this must be 2 and 6 to add up to 8. This can't be 6. Where is a 6 in column 8? It's column 9. It has to be here. So this is 6. This is 2. This eliminates 2 and 6 here. This is 0, 5. That means where is the 6 in this region? It must be here. So none of these can be 6 here. This is 0, 5. Where is a 7 in column 10? It has to be here. So there must be a 0, 7 pair here, which means this can't be 0. That means this must be, this is 1 through 5. This can't be 1 through 5 then. This must be a 0 here, which means this cannot be 0. So this can't be 2 here. Again, so in this region, what are the remaining digits here? Actually in this region, right? It cannot, these digits have to be the same as these 3 digits. So this is a 0, 7 pair, which forces this to be 13, and these 2 digits must add up to 17, 30 minus 13. So this must be 8 or 9. This can't be at 8, though, so this must be 9, which forces this to be 8, which forces this to be 9, which forces that to be 8. Okay. This becomes a 1, 5 pair here. These must be 1, 5 or 2, 4, adding up to, yeah. 9 cannot be here. These digits remaining are 1 through 5 with 9. 9 can't be here. This must be a 1, 3, 4, 5. Quadruplet here. 9, if you don't have a 9 here, you have the same problem, right? You have add up at most 2, 3, 4, 5. So this must be 9 here, which means this can't be 9. This 0 means this can't be 0, so this can't be 4. What else do we have? This is 9. The other 3 digits, you can't have 0 in any of them. So the other 3 digits must add up to 20 minus 9, which is 11. And the only combination would be 2, 4, and 5, with 3 unique digits out of 1 through 5. Right? You can't have 3, 4, 5, that's 12. You can't have 1, 4, 5, that's 10. You can't have 2, 3, 5, that's 10. The only combination from 1 through 5, which adds up to 11, is 2, 4, 5. So this is 5. This is 1. This cannot be 1 or 5 here, or 3. So it's a 2, 4, 9 triplet. That, again, leads this to not being 2, 4. Because if this is 2, 4, that eliminates 2 and 4 here. Both of these then would have to be 9. So this cannot be 2, 4. It's a 1, 5 pair. That makes this a 5, which makes that a 1. This can't be 1 or 5 here. This can't be 1 or 5 here. So this is still the same. This can't be a 3, 4 pair. One of these must be 1. This can't be 1. Okay, so this is all similar. This can't be 0, 1, 2. This can't be 0. So this must contain 2 here. We have a 1, 2, 3, 4, 5. Actually, triplet here, or quintuplet. That eliminates 1 through 5 in the rest of the column. 5 has to be one of these two, so this cannot be 5. Where we have a 1, 2, 3, 4 now, quadruplet in row 2, which eliminates 1 through 4 in the rest of the row. Therefore, this is 5. 5 cannot be in the remaining digits of the row of the cage, so this must be a 5 here. Therefore, this is 5 in 6, 9, or 7, 8 here. This must be 2 and 8 to add up to 10. This again must be 7 or 9. This is then 6 or 8 here. And 8 cannot add up with these digits. Well, maybe it could. Okay. That leaves these digits as 0 through 4. This can't be 5 here or 5 here. So 5 cannot be any of these digits. 5 has to, well, we already knew that. This cannot be 2. This can't be 1 or 5 here. This can't be 1 and 6. So this has to be 2, 3, 4, 3, 4, 5 here. One of these digits is a 0. One of these digits has to be 0, so none of these digits could be 0 here. This digit is the same as this. Right, so this is red. These are yellow again. So this cannot be 0 here. This is 2, 3, or 4. This is 1 or 2. This cannot be 0. So this is 1 through 4. This can't be 5. Where is the 5 in this? Well, it has to be one of these two. This can't be 1, though. This can't be 7. This can't be 8. Can this be 8 here? 8 and 5 add up to 13. So the remaining 4 digits must add up to 21 minus 13 if that's the case. 21 minus 13 is 8. And you have to have a 2 here. So there's no combination here that can add up to right. So this is 6, 9, 7, 8. This can't be 6 or 8. This must be the 7 or 9. One of these is 7 or 9. This is 7 or 9. This can never be 7 or 9. So it's 6 or 8. 8 and 5 add up to 13. So that would leave these 4 digits adding up to 8. Well, you could have 0, 1, 3, 4, but the problem is that would eliminate all possibilities here. You have to have a 2 here, which means the other 3 digits must add up to 6, with 1 being a 0. But you can't have a 5. And 1, 4, 0, 1, 4 adds up to 5. 0, 3, 4 adds up to 7. 1, 3, 4 adds up to 8, but you can't have a 0 with that because that would eliminate all possibilities here. Therefore, 8 does not work. This becomes 6. This becomes a 7, 8 pair, which forces this to be 9. This must be 6, which means this is 1, 2, 3, 4, which forces this to be 0, this to be 4. These 2 digits cannot be 4 here, so it's a 2, 3 pair, which eliminates 2 and 3 from the rest of the row. This must be 1. Therefore, this is a 1 here. And that's how you show that this has to be a 1 in this situation. And then everything else will solve from that. So this is the small correction that we had. And then everything else works that way. Apologies for this error. This was kind of a major error. I'm not used to digits 0 through 9 being there, so that was kind of my bad, just messing that up. I was just fortunate that that it solved that way, and I didn't have to backtrack through it. But obviously it's not that. Eventually you'll get to it, or I'll get to it. so it's not that bad of a mistake, unfortunately for me. But yeah, kind of a mess up here. Anyways, I hope you actually were able to catch this mistake and when you watched me solve it, and hopefully I won't run into this mistake again, and you won't either. But I'll see you next time on Frank Puzzles. Take care.